Hi, my name is Daniel, coach of Capgemini, and I'm happy to introduce our project Capgemini with our customer Konstantin and Fedor, our team lead Jan Philipp, and our developers Anna, Min, Michael, Daniel, Danny, Nicholas, Niels, and Thomas. Our app is a smart incident support for assembly lines. And now we want to show you our trailer. Have fun.
Annually, more than 70 million cars are produced in assembly lines worldwide. It is highly probable that during this complex and sophisticated process, manufacturing errors occur. Right now, the quality assurance process for assembly lines is very inefficient. This is where Capgemini comes in. The app allows the worker to automatically detect visual damage, annotate and attach additional information, and forward the incident to a responsible mechanic. Later on, the mechanic can scan the car and receive additional information about it. He can see the exact location of the damages and is given suggestions on how to fix the documented incidents. After repairing the incident, the mechanic can mark it as resolved.
Hi, I'm Danny from our developer team. Imagine you're an assembly line worker in a car manufacturing and you just found a scratch on the car you're assembling. Right now, the process of reporting a damage is very inefficient. There's a lot of paperwork involved and it takes a lot of time to locate and measure the damage. From now on, we call a reported damage an incident. In case you're not capable of fixing the damage yourself, you have to forward the incident to a responsible mechanic. This is very complicated and take a lot of time. Our app, Capgemini, improves this process and makes life a lot easier. The app offers the option to automatically detect damages through machine learning components, as well as relocating incidents in an augmented reality environment. Now I would like to introduce Min, who will give you a brief overview on our system.
Thank you. I'd like to start off by introducing the key class in our problem domain, the car. A car consists of different car part components, and the way we decide to model each one of them is by using the composite pattern. The idea behind it is that each component can again have smaller subcomponents and so on. So an example which we're thinking of is a wheel. A wheel is obviously part of a car, but then a wheel also has a tire and a rim, and these parts can now be modeled in depth down to even a screw if that's what's needed. Each component can have no damage, a damage, or a few damages to it. And some examples for a damage could be a scratch or a speaker malfunction, but these 5 taxonomies that you see down here, they're just examples, so they can be extended if necessary. Then next up, I'd like to show the incident class. The way we decide to model an incident class is if a damage is spotted by a worker, we automatically assign it a corresponding incident, meaning if a damage does not have an incident, it has not been spotted so far. The incident is the main class in our model because it has a very interesting behavior. It has a private method called suggest, and what suggest does is it provides a proposition on how to fix the damage associated to the incident. Incident also has a status and an attribute called status, and what status does is it gives information about the current progress on resolving the incident. In case a description attribute of incident is not enough information, there's also the possibility of adding additional attachments to the incident to clarify what the damage really is. Some examples for an attachment could be a picture, an audio recording, a video, or a document such as a manual with instructions on it. Then I already talked about him briefly, but now you can see his iconized version, the worker. The worker is the person who operates the app and is actually an abstract class in our class diagram. And the reason for it is because we want him to be instantiated as either a quality inspector or a repair mechanic. The worker accesses the incident during runtime, and depending on his role, he has a different functionality. If the worker is a quality inspector, he creates an incident after he has spotted a damage, and if the worker is a repair mechanic, he resolves the incident after it has been created before. Then next up, I'd like to show you the few steps which we have taken to derive the subsystem decomposition from our analysis object model. First of all, we group them into 5 packages and merge them into 3 separate subsystems. Then we used the facade pattern and introduced 3 APIs called Scan Detect, Report, and Resolve API. The Scan Detect API is probably the most interesting one out of these 3, which is why I'll talk a little bit more about it. It has a method called scan. Scan originates from the scanner package, and what scan does is it allows a worker to scan a car or a car part and then provides him with basic information about it. Detect comes from the detector package, and detect automatically detects a damage in case there is one, and then gives a probability on what the damage could be. So for example, it says with a 95% certainty, this is a scratch. The 2 other APIs I think are very self-explanatory, but something I really like to emphasize because it was important to our customer is the worker as a whole is able to report an incident, but only the mechanic really has the skill set to fix the damage, and therefore only the mechanic class can call methods from the Resolve API. This is how our subsystem decomposition looks like as a whole. What we've done is we mapped each API from the facade pattern to a service and then derived all of the components in the subsystem from their matching packages. Then next up, I'd like to show you the hardware we're using. We're using 2 iPhone XS as our devices. They are both running the newest iOS version 12.1 as their operating system, and here's a quick overview of the instantiated components. We're using ARKit 2 as our scanner component, CoreML as our detector component, and we have a 3rd report component. The reason why we have 2 separate devices is because one will go to the quality inspector and one will belong to the repair mechanic. And if the inspector finds a damage and creates an incident, he can forward the incident to the mechanic using Apple's AirDrop. All right, that was it from me. Next up, I'd like to welcome Nick and Thomas to the stage, who will give you a quick demonstration about the current functionality of our app.
This is Thomas, quality inspector at our assembly line. He just received a new car and wants to find out its type and model. So he opens the Capgemini app and scans the car part. In our case, a really realistic looking dashboard. Within an augmented reality session, the car part is recognized and displayed. Now that Thomas knows which car is in front of him, he can start looking for manufacturing errors. Oh, I think the app just found a scratch on a dashboard. Because we didn't want to damage our quite expensive dashboard, we used stickers instead. Thomas can annotate the location of the scratch, and upon clicking on the annotation pin, he can see further information in a detailed view. Let's just make some changes to the status and the description. For further clarification, Thomas wants to attach a video to the incident. After marking several incidents, Thomas can look them up in a list view to edit or delete them. When he's finished with his work, he can send the dashboard object with the incident on it to a responsible repair mechanic who will start resolving the incident. Thomas' job is done for today. Back to you, Danny.
Thank you, Nick and Thomas, for the quick demonstration. As you saw in the demonstration, we are able to scan and recognize the dashboard as well as spot little stickers on it which represent our scratches. The user is able to detect and resolve incidents, and he can relocate these incidents in our AR view and attach additional information such as a picture or a video to it. Now to our future work plans. For the final delivery, we will use the dashboard which you might remember from the kickoff meeting. We will detect further damages and make our AR session compatible to multiple users. We will implement AR navigation arrows, which should help the worker to find the incident in the AR view. And we will implement AirDrop sharing for our incidents. This was a quick summary of our process so far. Thank you for your attention and see you at the buffet.